Welcome, College Algebra. Today, we need to make sure we have our notes out from yesterday. That was our 2.4 composition of functions notes. If you don't have those notes, grab them in the back of the room. They should be in the College Algebra organizer in the Wednesday slot for yesterday. So if you were gone yesterday, see if you can pick up with this. If you were here yesterday, you should be going ahead and trying number 3, 4, 5, and 6. If you need to rewatch one of these, feel free to do so to get that reminder. Then try them on your own as well. Okay. What I'm going to do right now is start talking about number 3 and just going through these. So if you need to watch, watch. Otherwise, pause it here and start playing it to watch and check your answers as needed. So for 3 and 5, these problems, what we are doing is finding f of g of x. Remember, that's the same thing as this. Personally, I always use this notation. For the problems on this side, number 4 and number 6, those are doing g of f of x, or this, still pronounced the same way, g of f of x. Well, reminding ourselves how this works, well, what we want to do is start with the outside function. The outside function is f. And what I notice in this notation is we are getting rid of x, right? We are getting rid of the x that is seen in this notation, and we are replacing it with g. So that means anywhere there is an x on this side, it gets replaced with whatever g of x is, which if you look at the top in this case is 2x. That gets squared, and then we could simplify that. 2 is being squared, that gives us 4. X is being squared, that's just x squared. So simplifying this then, 3 times 4 gives us 12x squared plus 2, and we have our answer. Same idea with number 4, but now the outside function is g, so I could start with that one. Again, I want to take anywhere there is an x and I want to replace it. In this case, we are replacing it with the inside function, which is f of x. That means anywhere there is an x, I need to change it. All of the x's are changing to x squared plus 1. That is f of x. From there, we just need to simplify this as much as we can. Everything is under the square root. Those parentheses aren't really doing anything, so we could just drop them and get x squared plus 3. Because it's adding underneath the square root, we cannot take the square root of any of this. So it does have to say x squared plus 3 all under the square root. 5 and 6, same idea. If you're good with these, just check your answers at the end. If we need to watch them and double check, definitely do so. Otherwise, you'll see my work here. On this one, we were replacing x with g of x. So 1 over, get rid of the x, replace it with 2x plus 4, and bring everything else with. Notice the 4's in this case will cancel, leaving us with 1 over 2 over x. Remember, when you divide fractions, the saying for that is copy dot flip or keep change flip. So that means we copy down the first fraction, which is technically 1 over 1. We change it to multiplication, copy dot, and then flip the second fraction, x over 2, which just gives us x over 2. Remember, multiplying is just done across. So 1 times x is x, 1 times 2 is 2. 6, double checking as well if we need, starting with the outside function, which is g in this case. Taking g of f of x, so plugging in f of x into this problem. So get rid of the x, change it to 3x minus 7. From here, just simplifying so we could distribute to the inside on the bottom of that fraction there. And then combine our like terms on the bottom, 6x minus 15. And that looks like a good answer to me. So looking at some other stuff then, the interpreting composite functions. Oops, ignore that. Interpreting composite functions, the function C of S gives the number of calories burned completing S sit-ups. S of T gives the number of sit-ups a person can complete. Interpret C of S of 3. Well, the first thing I notice is S of 3. So what would S of 3 be? Well, S of 3 gives the number of sit-ups a person can complete in T minutes. So what I'm seeing is 3 minutes is the input, where S is the number of sit-ups done in that time. So then if we take C of S of 3, we know it's in 3 minutes. We do a certain amount of sit-ups. And then the C, what does C represent? Well, it gives the number of calories burned for completing those sit-ups. So what does this mean then? Well, in 3 minutes, we do a certain amount of sit-ups, which tells us how many calories we have burned during those 3 minutes from doing the sit-ups. Practice, same idea there. The function D of P gives the number of items demanded when the price is P. The production cost C of X is the cost of producing X items. Write a function to determine the cost of production when the price is 9. Well, if the price is 9, that's what I'm starting with. So what I see is price is P. Okay, that means I need to start with the D of P function where we know the price is $9. But what we want is a function that determines the cost. Right now, if I plug 9 into this function, all it is doing is giving me the number of items demanded. So how can I find the cost? Well, the cost, which is C, is the cost of producing X items. So we could end up taking C of that function. So when the price is $9, you make a certain number of items. That's what this is number of items. And then C, given the number of items, what we find is the cost of producing them. When you do this sort of problem, just pay attention to the units. It should make your life a lot easier. Let's continue. These next ones I think are pretty interesting. I think they're a little quicker for us as well. On A, one thing we can always do is just rewrite. I like to rewrite it like something like this. Notice now, though, G of 1. Notice there's a value on the inside. There's a value of 1 inside of the G function. So what that is telling me is I need to figure out what G of 1 is. Well, what that means is we need an X value of 1. So I'm looking in the X values. And then I need to determine the Y value that G gives us. So I find an X value of 1, and I need the G value at that time, which is 0. But realize that is G of 1. We need F of G of 1. So we need F of that value. So we are taking F of 0 now and finding that. Well, F of 0, that means I need to go to the X value of 0 and figure out what the F value is at that time, which gives us -1. That's how these problems work. So if you see that, you understand that, go ahead and try each of these, see if we can get through those. Otherwise, let's look at one more example. F of G of -1, start with the inside. Locate the X value of -1, that is right here. Identify the G value at that time, that is 0. Oh, the first one, it looks like I messed up because I went to 1 instead of -1, but it looks like those are actually the same values there. So it still worked out. Okay. Part A, my fault. I meant to look here at the X value of +1. That still gave us 0 though, so our input still worked. So let's correct B, make sure we're doing it correct. So G of -1, here's the X value -1. Find the Y value at that time for the correct function, that's 0. Now we can input that into the outer function. So now we find 0 in the x spot, here it is, and locate the y value for f, which is -1. Okay, let's look at one more example just to make sure we're not confusing any of this, not making any of those mistakes like I just did. So rewrite it if we need to. Now I'm finding -1, but that -1 is inside the f function, so find the x value, -1, here it is. Now I need to find it for the f function, which is here. That gives us -3. Now we take -3 and plug it into the outer function. So -3 is located here. I need to find what g is at that time, which is 8. Double check your answers for these other ones. Again, pause the video if you need so you can try them on your own first and then rewatch it to see if we agree. Here's what I would get for the next two though. X value of 0, find f, plug that into g, g of -1, find -1 again, find the g value this time, which is 0. Same idea for the others, g of -2, -2, find g, which is 3, so I need g of 3, here's 3, find g, which is 8. F of -1, find -1, find the f value, plug that into the outer function, find -3, find the f value, that's -7. Same idea if you have a graph then, you're still going to use that same idea, that same format. Be careful when you do this, because when you are given a value inside the parentheses, remember it's always x, so you're identifying the y value. This picture, this graph is also kind of confusing, so go slowly through these just because there's a lot of coordinates going on. Make sure we're looking at the right ones. So what I see first is we are looking at f of -1. So I need to find an x value of -1 and determine what the f value is there. So here's -1. Notice f is the bottom function, g is the top one. So I go to this coordinate here because that is on the f function. We need the y value there. The y value is 1. So I am finding g of 1 then. So I go to the x value of 1, find it on g. G is up here. Take the y value, which is 4. Let's look at it for B. For part B then, we need to find g of 4. So go to the x value of 4, find it on the g function. Right there, take the y value. So now I need f of 2. Now I can go to the x value of 2 and find it on the f function. That's the function down here. Take the y value at that time. That's -2. This process is just the same then. Go ahead and pause the video, get through each of these on your own, and then come back, play the video, and see if we agree. So looking at my answers, here is what I get. G of -1 gives us 3. So f of 3 then is right here, which is -1. F of 0 is 0. So g of 0 then, go up, and it looks like that is 5. F of 1, go to an x value of 1, find it on the f function. That looks like a value of -1. Go to -1, find it on the g function, and you get 3, and so forth. My other answers then are -2, +1, and 4. Double check those. If you have questions, try and help each other out on those. Otherwise, evaluating for a function, let's go ahead and look at this now. So this process still works the same way. We still have a value inside of a function. So I still want to figure out what the inside value is first. For example, h of 1, that just means this is an x value of 1. So I would take this function, get rid of the x, and as I get rid of the x, I'm just plugging it in and replacing it with 1. We could find that value. 3 times 1 plus 2 gives us 5. But that was the inside. That's what h of 1 is. So now if I need to find f of that value, I'm just plugging it in here. Now I'm going to the f function, which is at the top there. I'm getting rid of the value, getting rid of the t's and changing those to 5s. As we do so, we end up getting a value of 20. Same process for these other ones then. Take the inside function, plug into that, and then whatever the result is, you take that result and you plug that into the outer function. And we get something like this. Continue that process for each of these. Go ahead and pause the video here. Try that on your own. And then once you're ready, pick back up and let's see if we got these right. Going through checking answers now. Let's see what I get. Careful when you plug this one in. Negative 2 squared is positive 4. Negative makes that a positive, so you do get a 6 here. And then we're plugging that into h. And that, I believe, gives us 20. Double check for the bottom ones, g of 2. Notice we have 2 new functions now. This looks like it gives us 1. And then I also need f of that value. So 2 times 1 squared plus 1, which that gives us a value of 3. Same idea, B and C as well. Plugging in there, type that into Desmos if we need. We get a value of 9. Plug that into the outer function g now. And get 22. Last one, f of 0. F of 0 would give us positive 1. So then f of that value, notice we're doing f of f. Plug in 1 again, and that gives us 3. Okay, make sure we're double checking our answers there. If we need more help, talk with each other, please. Definitely help each other through this stuff. So number 3, just looking at this word problem, the amount of bacteria in a refrigerated food item is given by this function. So pay attention to the units where T is the temperature. When the food is removed from the fridge, the temperature is given by this, where T is the time in hours. Find the composite function. What is the amount of bacteria after 2 hours? Well, realize little t is the time. So we know t equals 2. So I could plug that into this problem that they are giving us. So I could evaluate each of these parts then using our calculator as needed. I get 15.2 for that, and then we take that value and plug in to the n function. This one might look a little bit more complicated, so utilize Desmos. Type it into Desmos. I get 3,519.8 bacteria at this point. So then the last parts, 1, 2, 3, and those 2 on the bottom. It says to decompose a function, we can write it as a composite of 2 similar functions. I don't know a great way to explain this if I'm being honest, but what I am paying attention to is the one function we are given, 5 minus x squared. And when I look at 5 minus x squared, I want to see that in this original function. Notice the 5 minus x squared is what's below here. Well, that entire part is g of x. So that means we were taking the square root of g of x. But if I plugged g of x in somewhere, that meant we were replacing the x variable. So if I see 5 minus x squared, we're going in the reverse. We're decomposing. So if I see 5 minus x squared, I'm going to change that back to an x, doing the reverse of what we were doing originally. So what is our function then, f of x? Well, that would have just been the square root of x. Because if we look at this as f of g of x, that means we would take the outside function square root of x, we would plug in and replace that x with whatever g is. That means this x changes to 5 minus x squared, and that verifies we did this correctly. So I look at this next one. I see square root of 4 plus x squared. That's this entire part. That means whatever I circled there, I'm just going to replace it with an x. And that must be what this original f function is. This next one, I see x to the 12th. Here I see that exponent of 12 on these parentheses. So that tells me here that something getting raised to the 12th. Well, what's getting raised to the 12th? X plus 6. So the x plus 6 is the new part. A little bit weird, but let's see how this looks at the bottom then. All right, let's go ahead and look at the bottom, number 1 and number 2 here. Be careful as you go through this process. Notice we want f of g of h of x. So let's just start with the inside g of h of x. Remember, when we do this composite, we always start with the outside function and we plug in whatever's inside of it. So that means I'm starting with the g function, which is x minus 6, and we are plugging into it. That means I'm getting rid of x and I'm replacing it with whatever h is. That's the square root of x. So now, whatever that is, we need to plug that into the f function. Notice g of h of x is inside of f. That means I'm starting with the f function, and I am replacing the x with whatever g of h of x is. So we got rid of the x. I'm plugging in the square root of x minus 6, but there was an exponent of 4 on that, so we need to make sure we raise it to that 4th power. Let's try number 2 first, so you can pause the video here and then see if we agree. Number 2, let's see if we get the same thing. G of h of x. I'm starting with the function g. I'm replacing x with the inside h of x, which is x plus 2. From there, we need to take that result and now plug it into plug it into f of x. So I'm starting with f of x, which is x squared plus 1. I am replacing the x with g of h of x, which is the 1 over x plus 2. Don't necessarily need to simplify these. They will not simplify nicely. That is it for our notes. Hopefully we were able to get through all of that.